Hi, it's Ryan. Today we're going to talk about Kirchhoff's rules. Kirchhoff's rules is a completely independent way of analyzing circuits, and you might even note to yourself that usually we use Kirchhoff's rules if there are ever multiple power supplies in a circuit. So we must use Kirchhoff's rules in a circuit with multiple power supplies. You can use Kirchhoff's rules for any circuit, but this condition must be true, or you must use Kirchhoff's rules if this condition is true. Kirchhoff's rules generally can be broken into two categories. The first is called the Junction Rule. The Junction Rule. And the Junction Rule simply states that the current into a junction is equal to the current out of a junction. The current into a junction is equal to the current out of a junction. And then, of course, we can represent that statement mathematically. I would like to note that this rule is derived from a very fundamental law of the conservation of charge. We know that there can be no buildup of charge at any point in a circuit that a current is established. The current is always going to flow, which is a little redundant throughout the circuit. So there at no point should be a culmination or a collection of charges within the circuit, like stationary charges. There should be no buildup. Mathematically speaking, the current into a junction will always equal the current out of said junction. And we'll see this in our examples that we do. The other set of rules are known as the loop rule. The loop rule and the loop rule simply states that the sum of the voltages around any closed loop is equal to 0. The sum of the voltages around any closed loop is 0. And so, of course, we'll give you this mathematically. But this is derived from the conservation of energy. Namely, what the battery giveth, the circuit taketh away. But of course, we'll represent this mathematically as well. And that tells us simply that the sum of the voltages around any closed loop in the circuit is equal to 0. And finally, to finish out this video, we're going to give you all of the conventions, all of the things that we want to hold true to when we apply Kirchhoff's rules. So we're going to label this next component of our notes as conventions. And this is going to seem a little bit strange, but once we do our examples, it should all come together. So I'm going to give you some conventions here, some rules that we hold to when we're applying Kirchhoff's rules to a circuit. So our first convention, the first thing we're going to do is we're going to label our currents arbitrarily. So we'll say currents are labeled arbitrarily or randomly. In other words, no preference to direction is given. No preferential direction. No preferential direction is given. Next, we're going to label all of our loops arbitrarily as well. So we'll say loops are labeled arbitrarily. And we'll say such that, ST is such that the following conditions apply. And so our first condition is that if we travel through a battery from high potential to low potential, and we really should be the current. If the current travels through a battery from high to low potential, in other words, from the plus to the minus side of a battery, then the voltage drop is negative. The opposite is true if we go from low to high. So we'll say if we travel from low to high potential, from minus to plus in the battery, then the voltage drop is positive. Next, if we follow the current through a resistor, if we follow, I'm going to underline follow, the current through a resistor, then the voltage drop is negative. In other words, V equals negative IR. Oops. And finally, if we do the opposite, if we go in the opposite direction as the current through a resistor, then the voltage drop is positive. V equals IR, or in other words, a positive IR, just to make it perfectly clear. Again, we're going to see all of this in action in our examples, so just bear with me. The last 2 points I want to make for this video is that commonly we will use one more loop rule than junction rule to solve a Kirchhoff's rules problem. So this is a common rule of thumb. So we'll say commonly we will use one more loop rule than junction rule when applying Kirchhoff's rules to a problem or a circuit. And even though I already stated this, I just really want to drive it home. We must use Kirchhoff's rules for circuits with multiple power supplies. So those are the Kirchhoff's rules and all of the conditions and things that we want to follow. And in the next couple videos, we'll do an example. We'll do two examples using Kirchhoff's rules to help drive these ideas home.